We're still looking at the law of sines, which is the one we started with yesterday, and I don't have it written on this page because it's pretty easy to remember. This one, though, is what we call the ambiguous case. Ambiguous means unsure. This would be when they give me two sides of the triangle and they give me an angle that is not between the two sides. So we call this side-side angle case. Now, there are possibilities with this where the information that they give you either makes exactly one triangle, or it might make two triangles, or it may make no triangles at all, which is why they call it ambiguous. The information that's given doesn't necessarily make a unique triangle. So these are all of our conditions here, all of our possibilities. I'm going to see if I can illuminate to you why this is. So rather than going through and looking at those and really belaboring it, the only ones I really want to look at would be if the angle is obtuse, because I think this is kind of a nice way to look at it here. So if the angle that they give you is obtuse, you have two possibilities. Either you have one triangle or you have no triangles. There's no possibility for there to be two triangles on this one. So in order for there to be a triangle, the side that's across from the angle that they give you has to be bigger than the side that's next to it. So if that one's longer and your angle is obtuse, then it's definitely one triangle. If you've got an angle that's obtuse and the side that across from it is shorter than the side that's next to it, then that one makes no triangle at all. So that's a case that I just kind of like to go over first because that one kind of makes sense. If this angle is obtuse and the side that's across from it is shorter than this side over here, then it's not going to be long enough to make it all the way down here to actually form the triangle. It would have to be longer than the side that's next to it. Alrighty, for the rest of those, we're just going to go through and look at the examples. We've got 6 examples down here, and I want to look through those examples, and I want to focus first on the examples that have obtuse angles, because we just talked about those, and those are easy. So the angle that they gave me on this one is 100. That one is obtuse. So if I were to draw myself a diagram of this, I would have my angle A over here. I've got an obtuse angle, which is 100 degrees. And then I've got this triangle over here where the side across from this one, which would be this side over here, would be my A. That one's 3. And the side that's next to it over here is going to be my B, which is 4. And so I'm trying to determine if this is going to make one triangle or no triangle. Now, because the side that's across from it is shorter than the one that's next to it, that means that this side over here is not long enough to make it down here to create a triangle. It would have to be longer than the one that's next to it. So this one is actually no triangles. Alrighty, so that takes care of all of the obtuse angles in my problem set here. So I'm going to move on to another problem here, and we're just going to feel our way through here. So with this one, they tell me that the angle is 50 degrees. I'm looking at A. So I'm going to draw myself a little diagram here. I'm going to make this angle look approximately 50 degrees. I probably drew it a little bit small, but that's okay. The side across from it is, because this was angle A, the side across from it is side A. So this side is 8. And the side that's next to it is going to be B. So this side over here is 10. And now to determine whether or not this makes a triangle, first of all, if the side that's across from it is longer than the side that's next to it, and you have an acute angle, it's going to make one triangle. This one, though, we've got the side that's across from it is shorter than the side that's next to it, so it's not that case where it's definitely one triangle. What we need to do on this one is we need to see if this side over here, this A side, is long enough to actually make it to the bottom. So to do that, I want to compare it with what it would take to make it to the bottom with the shortest possible distance. So if I draw that in, that would be the height of the triangle that I'm making here. So if I wanted to figure out what this height is, I can focus just on the left side of this triangle here, which makes a right angle. That's kind of nice. So my right angle there, I can use my right triangle trigonometry to figure out what that height is. So let's see. In relation to the angle that I know, that side is the opposite side. And I also know the hypotenuse. That side that's labeled 10 there is my hypotenuse. So I could say that sine of 50 degrees is equal to h over 10. And then if I were to solve that for h, it would be 10 sine of 50 degrees. Okay, so now I would need to calculate that so I can find out if that is more than 8 or if it's less than 8. So I'd put that in my calculator, 10 sine of 50 degrees. And my calculator says that that is approximately 7.66. Okay, so the shortest distance from the bottom is 7.66. The side that I have to work with is 8, which is bigger than the height of the triangle. So that means it is in fact long enough to get to the other side there. So if I continue drawing this, it would actually make it to the other side because it's bigger than the height. Now this is where it gets really interesting. Since I don't know what this angle is up here, they didn't tell me, then I could make this triangle by drawing that side A out this direction, but I could also draw it this direction, and that would make another triangle over here. So I've got this little interesting, very obtuse looking triangle here. So that's a second triangle. So this case here, where the side that's across from my angle is actually longer than the height, makes two triangles. So this is a case with two triangles. Okay, so we're going to try that with some of these others here. I think I'll do one more with you, and then you'll try the other three on your own. So I think the one I want to try with you is maybe this one. No, let me do a different one. Let's do this one over here. Okay, so we're doing F together here. So I'm going to start by drawing a picture of the triangle. I've got a very acute angle given here. That's my angle A, 30 degrees, kind of small. The side across from it is little a, so that's 80. And the side that's next to it is going to be our little b, which is 150. So the side across from the angle that I'm given, again, is shorter than the one that's next to it. So that means there's a possibility it's not long enough to make it to the bottom. So I'm going to draw on the height of this triangle, and I'll label it H. And then to find the height of the triangle, so I can see if 80 is longer than the height, I would take the sine of 30 degrees equals H over 150, and then I would solve it for 150. I mean, sorry, for H, so that'd be 150 sine of 30 degrees. Now this is actually kind of a nice one because sine of 30 degrees is something we can calculate exactly, and it actually comes out to a nice fraction. Sine of 30 degrees is 1/2. 30 degrees is one of my unit circle numbers. So this is 150 times 1/2, which is 75. And so the height of this triangle is 75, which means the side across from it is long enough to make it to the other side. So I could go ahead and draw in the rest of the triangle here. I know it's long enough to make it there. But this is another one where I don't know the size of this angle. So that means that this one would make a second obtuse triangle over here, like this as well. So this is another case that has two triangles. Okay, so now you need to experiment with this one and this one and this one. and see if it makes one triangle, two triangles, or no triangles. And then fill in the answers on the Google Doc. Google form.